So in this video I'm going to discuss code forces around 959 rated for division 1 and 2. So I will be solving first three problems of this set. So let's start with this problem. Problem number A. So in this question I will be given a matrix of size n into m of n rows and n columns, and each of the number in the matrix will be from 1 to n into m. So you can notice one thing, that all of the numbers will be unique in your matrix. Okay, so you have to construct another matrix B such that none of your a of I is b equal to b of I. Okay, and all of the numbers in the another matrix B would be also from 1 to n into m. Okay, so tell the question like whether the answer is possible or not, or if the answer is possible then print the respective array B. So I think so the answer is pretty much straightforward, because if your n or m are equal to 1, so the answer is no in that case, because the only number present in the matrix is 1 only, and the another matrix which you can generate is also 1, so both of the matrix would be same. So answer is no in this case. But every other case, you know one thing, that every number is unique, and every number is occurring one time only. So you can simply print the matrix in the reverse order, you will get the answer, because this is the solution in of this answer of this problem. Because like if you take this example, 4 to 1 9 8 3 6 7 5, so if you print the matrix in the reverse order, each and every number would be not equal to the number which is on that index only, because if you replace 4 with 5, these are not equal. You know one thing, you know this thing. So answer in this case, in this question, is this only, like print the matrix in the reverse order. If n and m are equal to 1, then print -1, else print the matrix in the reverse order. So let's now discuss the problem B, that is fun game. So in this question we are given two two arrays s and t, and these two are both binary matrices. So okay, what you have to do, you have to tell whether you can make t from s or not, and what is the operation provided to you. What you can do, you can simply choose index I, a number l and a number r. So what you can do, you can replace s of I with, this is I, s of I xor s of I minus l plus 1. So by this operation you can clearly notice one thing, that you can make XOR of any number with any previous number. Okay, this is the one observation. Okay, so let me tell you another observation. If your first number is 1, if your first number is 1, you can clearly make any string. Okay, which means the if your first, wait a minute, sorry. So if your first number is 1, you can make t every time. But why? So let me tell you why. Because you know one thing, that XOR of same numbers is 0. If you take XOR of this with, if you take XOR of 1 with this one, the both the numbers are same, and this number will be replaced by 0. Okay, now you notice one thing. If you make XOR of this number with this number, which means 1 with 0, then you know XOR of not equal numbers are equal to 1. So you have covered both of the cases. If your first number is 1 and you're counting a 0 1, then you can also make, and if you counter a 0 1 0, you can also make. So in both of the cases the answer is yes. So which may prove one thing, if your first index is 1 in the s, then answer is always yes. But if this is not the case, but if this is not the case, let me tell you another case. Like if okay, so if your new array is like this, okay, if your new array is like this, so tell me whether you can make both of them equal. Yes, you can make, but why? Like your first starting one is from here, and you know one thing, your first starting one is from here, and you know one thing, that all of the previous digits are already same. So you know, so you are no longer need to perform operation on these previous substrings. So the answer is clearly yes, because you can make uh, numbers equal using this one only. Okay, great. Now tell me one thing, like if here it is not 0 but here it is 1, can you make them equal now? I think so you cannot make equal. But why? So you can make this thing equal. You know one thing, you can make this substring equal, because it is starting from 1. But what will happen to this substring? So the operation you can perform, and you can perform to make this 0 equal to 1 is this operation only, right? But you know one thing, the operation of same numbers is always 0, so you cannot flip this bit. So answer is no. So in generalized way, if your first number is, if your I is equal to 0 is 1, then answer is always yes. Okay, but if it is not the case, like the first one in the S is not on the zeroth index, then what you have to do, you have to simply compare the previous strings behind the first one. If they are equal, then answer is yes, else answer is no. Let me take another case. Like if this is your like two strings, and here it is 1 0, now it is does not matter. So is this answer one or no? Answer yes or not? Answer yes or not? The answer is yes, because first starting one, because one is starting from here, and you know this thing, the all the digits previously behind this one are already same. So answer is no in this. Answer is yes in this case. But if I replace this zero with this one, this zero with one, or this with one, can you make them equal? You cannot make them equal. So answer is simply no. Hope so you have understood the problem. So let's now discuss the problem C, that is Hungry Games. So in this question you will be given like let me tell you the problem statement. You will be given some number of mushrooms. Okay, some number of mushrooms are given to you, and what you can do, you can simply choose two integers L and R, and you want like mm, let me tell you the case, like here only in the this part. For example, this is array given to you, 2 3 4 5 6 7 8, and there is also a number given to you, that is x. Okay, that is x, and this is x. Okay, so you can, what you can do, you can start from any index and start eating mushrooms from this index to any another index. Okay, great. Now what you will do, you will maintain a sum of this mushroom number. Okay, I am telling you in a simplified way. You will make a you can you will make a sum of this mushrooms, like eating from this index, 4 plus 5 plus 6. Okay, 4 plus 5 plus 6. But if but if at but if at any case if at any case your sum exceeded x, like for example in this case your sum would be 15. Okay, and your x is also 15, and your x is also 15. So in this case the sum till 6 would be 15, right? But 15 is not the case. If your sum exceeded x, or if your sum is equal to x, then you will reset the whole sum. Okay, you will reset the whole sum, which means at this point your sum would be 0 only. But what is the sum at this point? The sum at this point would be 9 only, because the sum has not exceed, because the sum is not equal to 15. Okay, great. And at this point it is 4 only. Okay, great. Now what is the sum at this position? Now you one thing, your sum is already reset to 0, because because your sum is equal to x. But after that you can start adding it again. So 0 plus 5, 7 is 7, and 7 is not equal to 15, so sum at this position would be 7. Okay, hope so it is clear to you. Now what the question is asking you to do, simply tell number of coordinates. Okay, number of coordinates such that if you choose I and j, if you choose I and j, okay, if you choose I and j, then the sum would be not equal to 0, right? Because if you take this index in this index, what is the sum? Sum is 9 and it is not equal to 0. Okay, if you choose this index in this index, what is sum is 0, so you will not choose this sub array, this 2 points or sub array. If you choose this 4 and this 7, you will choose this sub array, because the sum is not equal to 0. So you have to count the number of sub arrays such that the sum is not equal to 0, right? Hope so the problem statement is clear to you. Okay, so let me now explain you this question thoroughly. Like for example, these are the elements of the array. Okay, these are the elements of the array. Okay, now let's now take the first element. This is L. Okay, this is L. Left means, so what you can do, you can add the sum, and let's suppose at this position, let's suppose at let me change it. where I can change the pen. uh, I don't know. So let's suppose at this position, yes, it is clear. Okay, so let's suppose at this position your sum is becoming 0. Let me take another. For example, at this position your sum is becoming 0. Okay, great. Now what are the answer for this L? The answer for this L is this, the self index, this index, and this index. Okay, but he will not consider this index. Okay, now let's suppose the sum till at this point is 0, and at the sum at this point would be set as, let's suppose a. Okay, now at this point would be a plus b. For example, the value of this is b, a plus this is plus, and at this point the sum is again becoming equal to x. That means this is again a point at which the sum will be reset to 0. Okay, great. Now let's suppose again at this position it is 0. Now there is some, okay, let me change the color. At this position it equal to 0. Let's suppose there is some at this position, some at this position, some at this position, and some at this position also. Okay, now there are two checkpoints in the with respect to L. Okay, yes, there are two checkpoints with respect to L. Okay, let me erase this part. Now there are two L's with respect to L. So what is the answer for this L? So answer for this L is simply n. Oh, okay, n, the number of points minus the checkpoints. So the number of okay, so what is the size of the array? Size of the array is n minus number of checkpoints, that is 2. So the sum, so the contribution of this index would be n minus 2. So can we, can we somehow memorize it? But why? But how? So let me tell you how we can memorize this. So let me find the answer from the last. So what is the checkpoint for this index? What is the checkpoint for this index? So the checkpoint for this index is not there. Okay, so what is the answer for this index? The answer for this index is n minus its index. uh, yes, n minus this index, because what we will count, for this index we will always consider the elements which are in front of him, because this is L, and we will not consider the elements which are previous of this index. So we will simply multiply the total number of valid numbers which can be there for this index. But there, so there are total n minus I indexes which can be answer, which can make a point R such that the sum is not equal to 0. Okay, but and we have to also subtract the number of checkpoints. So is there any checkpoint for at this index? No, there's no checkpoint. So answer for this index is simply n minus I. N minus I. Okay, great. Now let me now traverse it back. Now you are at this position. Okay, now you are at this position. Now tell me one thing. You know one thing, that the checkpoint for this index is at this point. Okay, the checkpoint for this position is at this point. So you can simply count the number of, you can simply count the you can simply count the number of indexes between them, and that will be number of count for this. But you will also add the checkpoints which are valid for checkpoint plus one index. Okay, but why? Because you know one thing, that this is your this is your one checkpoint, this is not your checkpoint, but you will consider this part, you will consider this part, and you will also consider this part. But this index has already covered these three indexes. Yes, this index has already covered these three indexes. So what you will do, you will simply add the count of checkpoint plus one index. So you know, if you know the checkpoint for this index is at this position, the checkpoint for this index is at this position, so you will simply add checkpoint plus one index in the answer of this index. Okay, so that's how you can memorize it. So if you, now you are at this position, you know one thing, the checkpoint for this index is at this position, the checkpoint for this index is at this position. So what is the answer for this index? You will simply add, okay, so we will simply add answer of checkpoint plus one index to your current index, and also these two indexes will also be there. So that's how you can memorize it. So what is the main thing, in this question? just finding the checkpoint at each and every index. Okay, why it is coming? Okay, so what is the main thing in this question? Just finding the checkpoint for each and every index. Find the checkpoint, like here was checkpoint. Okay, find the checkpoint, and the answer for the current index would be his checkpoint plus 1th index, the sum of his checkpoint plus 1th index, right? So what you will store at this position? Now what is the question? What you will store at this position in the DP array, because it is memoization. You will store the number of checkpoint at this index. What are the number of checkpoint at this index? These are 0. Okay, great. Now at this point, you are at now this point. So if you are at now this point, the number of checkpoint for this is this only, and you will also count. Now you know one thing, that number of checkpoint for this is 1, because it is here also, and number of checkpoint plus add the I plus 1th index, because it will be same for this index also. So that is 1 plus 0. Okay, okay. Now you are at this index. You know one thing, there is one checkpoint for this L at this position. You will also add checkpoint plus 1th index checkpoint to this index. That is total will be 1 plus 2. 1 plus 1, that is 2. Okay. Now why I am storing the checkpoint, not the total number of subarrays? Because if you are having the number of checkpoint at each index, you can easily calculate the answer. But how? If suppose the number of checkpoint at this position is 1, now tell me how many possible R's can be there for this L. There can be total n minus I number of R's. And in these R's, what are these R's? These R's are simply these elements only, right? And in these R's, how many checkpoints are there? There is only one checkpoint. So simply subtract that checkpoint. Okay, and you will get the answer for this index. Great. Now you are at this position. Now tell me how many possible R's can be there for this index. There can be total n minus I number of R's for this position. And what you will subtract? You will simply subtract the number of checkpoints at this position. The number of checkpoints at this position would be 2. So the answer for this index is this only. You can simply generalize the solution, generalize the formula of this. But how to solve this problem? Like this is the brute force approach. First of all, find the all the checkpoints for each and every point, and the number of store the checkpoints as each and every index, and the checkpoints would be 1 plus checkpoint plus 1th index, right? And the final answer would be I minus n minus I minus number of checkpoints at this position for the current index, and sum up all of them and find your answer. But in this case, you have to find the checkpoints, and finding a checkpoint is an n square operation. But you cannot afford the n square operation. So let me uh, uh, show you a solution of an n square approach. So this is the simply n square approach. Mm, okay, so where is n square approach? Yes. So yes, this is the n square approach. So what I'm doing here is, now I'm maintaining a DP, CP count. But this is checkpoint count. By the way, this code is not mine. I found this beautiful written code in the editorial part. So uh, this is the DP array which I will be maintaining and traversing from the back of the array, right? And for each and every index, what I will do, I will maintain a count. I will maintain a count. But what is this count? This count is the simply next checkpoint, because what I am doing, I am simply calculating the next checkpoint, and I will find the next checkpoint, and the checkpoint count for this index would be checkpoint count of L plus, if your r plus 1 is smaller than n, if your r plus 1 is smaller than n, then you will simply add, because what is r is simply that index at your point. At that point your sum is becoming greater than x, because at that point your sum will be resetted to 0, right? And if your sum is being resetted to 0, at that point your sum would be become equal to 0, and you will become equal to 0, and you have to mark that index. And what I'm doing for each and every L, I'm calculating its next checkpoint. Okay, I'm calculating next checkpoint. And you know one thing, the total number of checkpoints at this position would be its next checkpoint plus number of checkpoints at its next index. So if my r is my checkpoint, Then I will also add the checkpoints are at r plus 1th index, and simply making the condition if it is smaller than or equal to n also, like this is the case. And what is the final answer? The final answer would be the check n minus I minus number of checkpoints for the ith index, because I have tell you the solution here, n minus I minus number of checkpoints in the ith position. Okay, so hope so it is clear to you. But this is n square approach. How you can optimize it? So you will notice one thing, that what I am doing, I will simply find the checkpoints. And what is a checkpoint? Simply think one thing. What is a checkpoint? Checkpoint is a dead point at which my sum from this index to this index is exceeding x. Is exceeding x. So you can simply use a prefix sum. Yes, I can simply make a prefix sum. Let's suppose the prefix sum of this is this. The prefix sum of this array is this. Okay, so tell me, can't you find the first index at the point your sum is exceeding x? You can simply find it with binary search or using a upper bound function. Like if your prefix sum till this point is x minus 1, and by using binary search upper bound function, you will directly find this position r for this cell. Yes, you can find. But if you are at this position, you want to find the checkpoint for this index. How you can find? Let me tell you here. Like if it is like prefix of, let's suppose this is j, prefix of j, let prefix of j, mm, okay, okay, prefix of j plus x, you have to find the first index whose value is greater than this value, right? So what you can do, you can simply make a binary search operation on this function also. Like, let me tell you here. You can simply make a binary search operation on this index also. Like if your prefix sum at j is this, okay, and your x is this, right? And you have to find the index at the point your prefix sum is exceeding x. Let me tell you here, like if your prefix sum is j and minus prefix sum of j minus 1, right? You have to find a prefix sum of x. You have to find a prefix sum of x such that prefix sum of prefix sum of x minus, let me, you have to find the index. This is x is your checkpoint, such that prefix sum of checkpoint minus prefix sum of j minus 1 should exceed x. So you have to simply find this only. So in short, what you have to find? You have to find such prefix sum which is greater than or equal to x plus prefix sum of j minus 1. If j minus 1 exists, then use j minus 1, else use 0. So you can simply find this p of x using upper bound function and implement the solution. So let me show the implementation also. Okay, so first of all, maintain a prefix sum. Okay, now in this question, like in the previous approach, I am finding the r by iterating it. Instead of iterating, just use upper bound function to find the sum. And what is the sum? Sum is simply n. Sum is simply prefix sum of l minus 1 plus x. Okay, and just using this r, check if your r is more than n, then simply use the dp array and find the number of checkpoint counts at L position, and the number of checkpoints at L position would be checkpoints at L plus the number of checkpoints are at R plus 1th position, and in the end answer would be n minus r minus number of checkpoints at I position. So this is the only explanation of problem number C. If you like the video, please don't forget to subscribe my channel, and please like, share, comment, and that's all for today's video. Thank you.